Welcome back to Science Sundays. And after the weather we've had the last couple weeks with it all over the place, from startlingly hot to surprisingly cool, 23 ABC's meteorologist Brandon Michaels and I wanted to give you an at-home experiment to help teach your kids about the weather and atmospheric air pressure. Check it out.
Hello everyone, I'm meteorologist Brandon Michaels, and I wanted to do an experiment with you today about atmospheric pressure or air pressure. And that's something, if you ever watch us do the weather, you hear us talk about a lot, has a big impact on the weather that we see on a day-to-day basis. But it's easy to forget that air pressure is always there. In fact, it's always pushing down on your body between about 14 and 15 pounds per square inch. So there's actually quite a bit of pressure in the atmosphere. You just don't notice it. But we're going to do a little experiment today. It's a very simple experiment. It's very cheap. It's one you can do at home, but with adult supervision, because we are going to be using the stove here, and this can is actually going to get very hot. So I've got this can, I've got it filled with just a little tiny bit of tap water. We're just going to set that on the stove. The trickiest part is getting it to balance. We're going to turn the stove on, and we're actually going to start to boil the water that's inside the can. And eventually we're going to transfer that can over here. And what we've got here is a bowl of very cold water, and we've actually put some ice cubes in it to get it as cold as we can. And it's very important that that water is very cold for this experiment to succeed. And then of course we've got a pair of tongs because we want to handle this can safely. Alright, so now we've got our can on the stove here. We can see that it's boiling. We can see the steam rising from the can. We can actually hear it boiling. And what we're going to do is transfer that can into the cold water and see what happens. Now, it's important when you put this can into the cold water, you put it in with the drinking hole, the mouth of the can, down. That has to go in the water because we have to seal off this can in order to take away the pressure. So let's do that right now. Okay, 3, 2, 1. Okay, so obviously what happened, the atmospheric pressure, the air pressure was strong enough to completely crush this can. So we're going to do this again here, and we're going to kind of break down the steps of what exactly is happening inside this can to let it be crushed by the air. So we've got another can that's boiling right now, and once it boils, you'll actually be able to see the steam kind of rising up. And what's happening is we are adding heat to the water, the liquid water, and we're turning it then into water vapor. And that water vapor is filling up the can. It's replacing the air that was in the can, but it's still the same pressure as it is on the outside. So you've got about 14 to 15 pounds outside and 14 to 15 pounds inside the can. When we transfer it over into the cold water, that cold temperature turns that water vapor back into liquid water. So we don't have that gas pushing on the inside of the can. The inside of the can, the pressure goes down to pretty much zero, but we still have about 14 pounds of pressure pushing on the outside of the can. So that's not balanced anymore, and this is exactly what happens. 3, 2, 1. The can is crushed. And it works every time, and it's a great demonstration of just how strong the air pressure is around us.
Now head on over to our website, turn23.com/Science Sundays, to get links to lesson plans in atmospheric pressure from our friends at the National Weather Service. We'll see you next week.